Megan.
I'm Natalia.
And welcome to our Hank Green and Bob Ross crossover, where we're going to learn about the history of microbial art, and then we're going to show you how to make your own microbial art in your own lab.
Okay. Microbial art sounds really cool. Who came up with this stuff?
It was actually Alexander Fleming, which you might know from his discovery of penicillin. But little known fact, he was also an artist. Fleming used different types of agar and different colored bacteria to paint. And this can be pretty difficult actually, because you have to find different colored bacteria and then grow them together so they all grow at the same time so you get a picture. These pieces of art don't last very long because the bacteria all eventually grow all over the plate and run into each other.
Wow, Megan, microbial art sounds like a very cool but complicated process. What are the methods to doing this stuff?
Well, Nat, to make these agar art pieces, bacteria is inoculated into the medium in a specific design with sterilized tools. Then these microbes grow into colorful artworks. Some popular bacteria seen in these artworks include Serratia marcescens, Micrococcus luteus, and Pseudomonas aeruginosa. Of course, we always want to make sure we're being safe when working with bacteria that could potentially make us sick.
Yeah, don't eat it. Wow, it sounds like not only you have to be well versed in types of bacteria, but you also need to be really well versed in sterile technique and safe lab procedures. I wonder if there's some sort of contest for this stuff.
Well, turns out there is. The American Society of Microbiology holds an agar art contest every year. The contest started in 2015 and has grown in popularity since then. People from all over the world submit their microbial art to this contest, and we're going to show you how you can do your own. So Nat, what materials are we using today?
Well, we're going to be using plenty of different materials, just like any good artist would. But first and foremost, we need to address the most important part about working with bacteria: lab safety. You always want to be wearing some thick protective glasses to protect your eyeballs and a lab coat to protect your skin and clothes. You don't want any of this nasty stuff getting on you because you will get sick and you will die. As far as our materials go, just like any artist has its paintbrush, a microbiologist has their inoculating loop. Today we're going to be using plastic inoculating loops like that are used in hospitals. However, if you're using a different inoculating loop, such as a metal one, you want to make sure you're practicing sterile technique by flaming it before and after every use. This prevents the cross-contamination of other bacteria and prevents you from potentially very much messing up your artwork. So, if our inoculation loop is our paintbrush, then our agar plates will serve as our canvas. An agar plate is a petri dish that's filled with a nutrient gel. These are commonly used in microbiology labs to grow bacteria or fungi. And there's a variety of agar plates available for us to use in the microbiology lab, all of which have different available nutrients that can help or hinder the growth of certain organisms. Today we'll be featuring Mueller-Hinton and TSA. This is a TSA plate, otherwise known as tryptic soy agar. This medium is used for general isolation of bacteria, while this plate, Mueller-Hinton, is a media that's commonly used for antibiotic susceptibility testing. Both of these plates are non-selective, which means that most organisms will be able to grow successfully on them. However, given the difference in compositions of these mediums, we may be able to see a difference in results even when inoculating the same species of bacteria. There's a countless number of bacteria that you can use for your microbial art. Today we'll be going over some popular options that are used when making microbial art. Our first example is called Micrococcus luteus. Ooh. Micrococcus luteus is a gram-positive cocci that can be found in a multitude of places, including soil, dust, and even your human skin flora. M. luteus is likely to give us bright yellow colonies to work with in our art.
Pseudomonas fluorescens, kind of a green color, is a gram-negative rod-shaped bacterium, and it is incredibly motile. And it is able to grow very rapidly in a laboratory. It's obviously kind of a green color. This one's a little faint, but it'll grow green.
Up next on our roster, we got Serratia marcescens. This is a gram-negative rod-shaped bacteria, and it's regarded as a facultative anaerobe. It's the most common cause for urinary tract infections. Serratia marcescens typically will provide bright red colonies to our color palette, but With all living things, they have variability, and these are not very red.
Staphylococcus aureus is a gram-positive cocci that is commonly isolated from infections within biofilm formations. Staphylococcus aureus can provide us with yellow or white colonies.
Lastly on our list, we have Pseudomonas aeruginosa. This is a gram-negative rod that's a facultative anaerobe, and it's a common pathogen in plants, animals, and people alike. When we inoculate Pseudomonas aeruginosa on the Mueller-Hinton agar, it turns this crazy green color. Well, Megan, now that we're all good and familiar with microbial art, what it is, and what we're going to be using, we can begin creating our living art pieces. We'll be looking towards the American Society of Microbiology for a guide for our tutorial. So we already have our prepared agar, and our colonies are ready to be inoculated. And with the sterile loop, Megan's just going to pick up a small bit of a colony on her loop. Keep in mind that these loops are plastic and sterile, but they're only sterile for single use. When she's ready to inoculate, she's going to take her loop and drag it across her agar plate in the pattern that she wants her bacteria to grow in. When she's done, she's going to go ahead and throw that sterile loop into the biohazard bin before she picks up her next loop. When you're ready to switch the bacteria you're using, you want to make sure that your inoculating loop is sterile, either by grabbing a brand new plastic one or flaming your metal loop until it's red hot and then allowing it to cool before you pick up your colony.
There we go.
Great. Now that Megan's plate has been successfully inoculated, this plate is ready to be incubated. A laboratory is a shared space, so you want to make sure that you're properly taping off everything and labeling things so people know that they're what they are and that they're yours.
Skipping with the bacteria in my hand?
Yes.
God.
Let's go to the incubator. Yeah.
Nat's going to be inoculating on a TSA plate with the same bacteria, but we might have different results because the different nutrients in the different agar might result in different colors.
Megan's inoculating a McConkey agar plate, and she's using a template as a base for her drawing.
Nat is now going to be inoculating some bacteria into a blood agar. Should produce some really pretty purple colonies.
Now that we have all of our microbial masterpieces ready to go, let's go incubate these puppies. Depending on the type of bacteria you're using, you're going to want to incubate it for a different amount of time or at a different temperature. We're going to be incubating these bad boys at 37 degrees Celsius for a couple of days. We'll see you. Well, hello there. It's been a few days. We've let our bacteria grow on their plates. Let's look at our results.
Here we have one of our Mueller-Hinton plates.
And here we have our TSA plate. Now, as you can see, our TSA plate and Mueller-Hinton plate kind of look a little different, even though we use the same bacteria on both plates. So, in our grass section of our flower, you can see that our Pseudomonas fluorescens turned out a lot more green on our Mueller-Hinton plate than it did on our TSA plate. That's because Pseudomonas fluorescens has a green water-soluble pigment, and since the Mueller-Hinton agar has a higher water content than TSA, it's going to be able to pull that pigment out and give us a more vibrant green color. We also wanted to talk about some plates that we inoculated that we did not mention in our tutorial. First, we'll start with our McConkey agar plate.
So this is a McConkey agar plate. We have the bacteria Serratia marcescens on it, and the McConkey agar selects for gram-negative bacteria, which Serratia marcescens is. And so on the McConkey agar, it turns this really pretty purple color. You can kind of see it's a little faint, but nice light purple. On a regular TSA plate, it'll be more white. The strain we have is a little more white when they're typically more pink, but on the McConkey, very pink.
And we also have our blood agar plate that also selects for gram-negative bacteria, and on here we have E. coli and Klebsiella pneumoniae. And as you can see, they've turned this very bright, vibrant purple color, which is not typical of both of these species of bacteria when they're inoculated onto a regular TSA plate, and that has to do with the lactose fermentation that these organisms are able to do when they're inoculated onto a blood agar plate or even a McConkey agar plate. Thank you very much for tuning into our episode. We hope you learned something. We hope that you try this out in a safe environment, in a laboratory preferably. Please don't do this in your house. And we hope to see your submissions in the American Society of Microbiology art competition one day. We know that we won't. Have a good one. Goodbye.